Welcome to the Machines and Molecules podcast. Machines and Molecules hosts guests that have backgrounds in chemistry, biochemistry, and machine learning. Our guest today is Patrick Torbey, who is the CTO and co-founder of Neoplants. Neoplants is a Paris-based startup that develops plants that purify air. Salut, Patrick.
Salut, and thank you very much for inviting me.
How are you doing today?
I'm doing good. It's intense as always, but today's a good day.
Okay, very nice. So what's intense at the moment? What bugs you at the moment? Is it more lab work? Is it business type of problems?
Yeah, I think it's a mix of both in the moment. So what we're building is this indoor plant that's able to absorb and metabolize indoor air pollutants. So it's
Mm-hmm.
genetically engineered with its microbiome that's engineered as well. And
Mm-hmm.
we finished after 4 years and something of R&D. We finished building our first product, and
Mm-hmm.
now is the phase when we do the pre-production quality checks, and it goes
Mm-hmm.
from an innovation to a product that will end up in people's homes. So
Mm-hmm.
this is kind of very unique moment in the company, preparing for our first product, and there's a lot of learnings we have along the way. So it's a lot of organization, a lot of I would say, much more rigorous and much more streamlined processes than you usually have in R&D. So it's a bit of improving on the management side and making sure everybody's aligned and understands the goals and what they have to do, and also on the
Mm-hmm.
technical side, how can we solve problems while improving the processes.
Mm-hmm. And you mentioned engineering the microbiome now, because we have listeners also with a background in machine learning. Can you explain what that means? What's the microbiome and what does it have to do with plants?
Yeah, for sure. So no plants live alone. So they always live with a community of fungi and bacteria that live in and around the plant. Same way as humans have gut bacteria, and gut flora. Same thing with plants. So plants usually depend on their microbiome for enhanced growth, pathogen resistance, a lot of different stuff. What we do is we custom design these microorganisms that we put in cohabitation with the plant around the roots
Mm-hmm.
and the soil. We optimize them for the absorption of these indoor air pollutants,
Mm-hmm.
formaldehyde, benzene, toluene, xylene. So the plant itself is genetically engineered to absorb those, but the microbiome as well can grow on those as sole carbon source. So it's kind
Mm-hmm.
of a natural air purifier that has these two systems uh, that work in parallel.
Mm-hmm. And probably a question that you get a lot is, well, do plants not purify air in and of themselves? So why do you have to
Mm.
engineer this?
Yeah, plants have interesting phytoremediation, so air cleaning capacities naturally.
Mm-hmm.
Although you need something like 20, 30 of them in a single bedroom to have an actual effect in real life conditions.
Mm-hmm.
So they have interesting properties. Some are better than others, but you will need to turn your bedroom into a greenhouse if you want to have an actual impact when it comes to
Mm-hmm.
your air quality. So what we do at Neoplant is trying to improve this indoor plant by 10, 20, 30 times so that only one
Mm-hmm.
plant is able to have this impact that would require 20 plants.
Mm-hmm. Okay. Um, so it's very similar in that respect, it seems, to a lot of other parts of biotech where, yes, you find a biocatalyst in nature, for example, that is able to catalyze the reaction you're interested in. Only the biocatalyst in nature works for whatever it's needed for and not in the circumstances that humans want it to work in, right?
Mm.
Yeah.
Yeah, yeah. So in our sense, these what we do is we take natural bricks that we find in different organisms
Mm-hmm.
and add them to the plant, optimize them to the plant. So it's taking them out of their natural ecosystem and trying to optimize them for the plant itself. So in that sense, it's totally correct that we're just taking a part that's developed by nature and putting it in somewhere where it can have a much bigger impact in real life
Mm-hmm.
conditions.
Mm-hmm. Yeah. And how did you get to that idea? How did you come up with the idea to do a startup at all? I think you have a PhD in genetics, and this probably in the minds of some people is not the main background you come from when you start a company. So how did you get the idea? How did you to do a company at all? How did you get the idea for what you want to do, and how did you meet your co-founder?
Yeah. So yeah, it's important to start with the fact that I'm not building this company alone. I have a co-founder called Leo that has a complementary background from mine. So I come from a tech background, as you said. I have a PhD in genetics and genetic engineering, and Leo has a background in product marketing. He was a product marketing manager at Google, launching new
Mm-hmm.
categories of products in different geographies before starting the company with me. So how did the idea come about? I think it first came about like this idea of building weird organism came about before I knew what was biology actually, when I was just fascinated by Pokemons like every kid my age. I always wondered, why don't they exist in the real world? Why can I see a giraffe but not a Pikachu? What makes nature do some things and not others? And very quickly I understood that it's due to one single molecule called DNA. And this one molecule calls for everything that's life. And I wanted to understand it. I really wanted to get my head around, if you do just one change, you can change an entire organism. That's just fascinating. And so I grew up in Lebanon,
Mm-hmm.
when I was 18, I moved to France to study that. So bachelor, master's in genetics, and then PhD in exactly that, genetic engineering of organisms to add or subtract functions. That being said, so I was super lucky to start my genetic engineering career at the very early stages of the CRISPR-Cas9 era. So I really
Mm-hmm.
saw the field going from what is that to everybody's using it and you'd be crazy not to use it. And I was fascinated by the power that these tools could have a positive impact. You could engineer anything you want. And I was frustrated that all the applications that I saw at the time were just confined to academia, like understanding something, or with application in pharma or medical applications, which is very much needed, but kind of missed this reality that we now can just create magic out of nature. And that's just fascinating. And I wanted to show people the power that these tools could have to have an impact in everyday life, not just when you're sick and when you have a problem, but just in normal, healthy life. GMO can be a great thing for you. So this idea was always in the back of my mind when I did my PhD. And afterwards, I was lucky enough to be accepted in a talent incubator program called Entrepreneur First, where they bring 50 people from various backgrounds inside one room. And it's kind of a speed dating process where you
Mm-hmm.
find your co founder and find an idea, build a startup all in 6 months. And after
Mm-hmm.
that, we were off to the races. So the idea came about Neoplants specifically is okay, we have the technology to create any weird organism we want. Um, what's the best organism to start with? We decided to start with plants because we're always surrounded by plants, whether it's indoors, outdoors, there's always plants around us. And intuitively, what was the most powerful function we could add to a plant? Well, it's the function to purify the air. So at first it was, okay, can we increase the amount of CO2 that's captured by the plants? The answer is yes, but little, and it's extremely difficult.
Mm-hmm.
But what if we could absorb something that's more harmful than CO2 for humans, at least, like formaldehyde, benzene, toluene? Well, plants didn't evolve at all to capture and metabolize these pollutants. So there's a lot of room for improvement that nature didn't explore in plants, but it did explore that in organisms. So this is
Mm-hmm.
how the idea came about. Like, let's consider this plant a black box that input gases, output other gases. So what if it could input benzene and output oxygen and turn the benzene actually into sugar and metabolites that it can use to grow? So it would be a
Mm-hmm.
natural air purifier that uses the pollutants to build more of itself. And that idea kind of stuck with us, and we never turned away from it since. It's been 5 years now.
Okay. So basically, the entrepreneur first, you called it a speed dating. I suppose it was difficult to otherwise get in touch with business people or marketing people, right? With your background, because you study genetics, you do a PhD in genetics, you're surrounded by academics, you never talk to people in industry, possibly, unless you enter industry. Was that one of the reasons for you to go to this program?
Well, I guess the reason was that I didn't have a roadmap. Like, I had an idea.
Mm-hmm.
It was a bad
Mm-hmm.
idea, by the way. Just I wanted to create something that was different, that was new. And I didn't know how to do this. So obviously, you need to
Mhm.
create a company, so you need some business background. Um, I had a bit of like team management, leadership background, but nothing in business.
Mm.
So when Entrepreneur First kind of contacted me, I was I could definitely see the added value that I need somebody to do this with me. At first, I
Mhm.
wanted to do this with my friend that was doing her PhD at the same time as I was.
Mhm.
But very quickly, we both got into this cohort, and very quickly we understood that we needed complementary backgrounds and not the same
Mhm.
background. So
Mhm.
it wasn't deliberately because I wanted to find a business person. It was more to find a path and to be kind of have an ecosystem that's around me to try to guide me. I think I
Mhm.
would have done a company uh, without entering entrepreneur first, and I'm sure that it would have failed uh, if I didn't go through this program and if I didn't meet Leo for sure. I learned so much more in 6 months of entrepreneur first than I did during the 3 and something years of my PhD. So definitely a great way to start a company is to find someone not only that has the business expertise, but that is also ready to create a startup because it's not easy to drop your very cushy job at Google and say, well, right now I want to create this crazy company that nobody has even seen something remotely like this before. It requires a certain personality and at a
Mhm.
very specific moment in people's careers. And so this is the added value of incubators like Entrepreneur First, where people are uniquely placed to create a startup and really want to do it right now.
Mhm. Yeah. Um, Cushy job at Google. That's a good point. I see that a lot with different people here in Berlin. It's not Google so much. It's more Amazon and Zalando, but very
Mm.
smart people get paid loads of money to do stuff that's not so important. So it's quite admirable, I think, also of your co-founder to leave such a job. Um, yeah.
Yeah, I think so. I think he's allergic to comfort. As soon as we get a tiny bit comfortable in the company, it's like, let's put another milestone here. And yeah, I
Yeah.
think it requires a specific mindset to get out of the golden cages of Google and start your own thing while being paid
Mm,
nothing to start with. Yeah. But yeah, as
mm,
soon as he felt comfortable at Google, he left, which I find interesting.
mm. And what excites you about this startup building thing, about the process?
I think what's interesting about startups is that you have an a really big amount of resources to build what you want to build. So the
Mm,
different so if you say take the same project and you just build it in academia, it would take
mm,
much longer to get the finances, much longer to build the team. The structure of academia doesn't allow you to actually build a product. It allows you to find out something about nature, but not
mm,
really building a product for various reasons. So you have much more resources and a huge pressure from everybody around you, investors and others, to build it fast and go to
mm,
market fast. And this
mm,
pressure, I think, is absolutely needed to create a product. So the science, like the level of expertise that we have in house, is on par and better than most of the labs that I know because we take the best
mm,
scientists in each field, in each lab, put them together to build this one product. But the difference is not really the science that we do, it's really about the organization that's around it. How fast can you build something? What are the
mm,
processes you put in place to build it? And this, I don't think, can exist outside of the world of startups. Even in industry, you have this inertia, you have this, well, if it doesn't happen this year, like if whatever Syngenta doesn't produce this type of plant this year, that's fine. Syngenta is not going to die tomorrow, Bayer is not
mm,
going to die tomorrow. This sense of urgency, like either you do this, you do every part of it extremely well, or you die. It's a very Darwinian concept, and it makes it so that only the startups that are extremely good survive. And uh, and I like it. I don't know. I'm attracted to this high risk, high reward, high intensity kind of lifestyle.
mm. Doesn't it also make you, or maybe not does it, but could it also make you sloppy? Especially coming from science, there's always this, I think, especially also for lab scientists, there's always this, oh, I have to make it perfect because there's so many ways it can fail. And I have to make sure that I don't fool myself, even, let alone other people. could this pressure also lead to this kind of phenomenon?
Yeah, I think I think it can for sure, and
Mm,
I think it does in a few startups. And it's really about the values of the company you're founding. What are you willing to do and not to do? So there's obviously pressure to do things fast, but at the end of the day, what matters is the product performing or not. This is the
mm,
lens to which we view the thing. So you can cheat about the data, whether it's for a startup or an academic lab. Like how
mm,
many times did you read a paper, reproduce the experiment, and oh, it doesn't work? So
mm,
the difference is, at the end of the day, you have a product, and either it works or it doesn't. Either people like it or they don't. And this is kind of well, the litmus test, right? This is
mm,
what allows you to say I did a good job or not. So
mm,
for example, in more concrete term, if we, let's say we study the plant and we find something very interesting about it, and okay, this is like, this doesn't work because this is a blocking point. Let's give an example of, okay, there's gene silencing when you put this promoter. When you try to activate this gene with this DNA part, the gene is not active. So two things: either you can study why isn't the gene active and solve the deep problem, and this
mm,
you have the luxury to do in academia and later on at a bigger stage company. But for
mm,
us, it's like, it doesn't work. Either we spend the next 3 or 6 months to understand why, or we test something else.
mm,
And the answer is always, let's test something else. So there's a lot of things we put in the freezer, a lot of cool things that we discovered along the way, that we
mm,
decided, well, it's not going to make the product better, at least not the first one. So let's put this
mm,
in the freezer and focus on the rest. But when it comes to quality check, when it comes to making sure that the data is correct, I don't think there's anybody that's more hardcore than our R&D team. So we
mm,
try to be as we go above and beyond what the scientific literature does and what like companies building air purifiers do. So we try to do different level of testing because at the end of the day, this will end up in people's home and will represent a new wave of product, like a synthetic biology product in your home. You want to have a good. The goal is not to make a quick buck; is to create this kind of new category of product. So you want to make a good
mm,
first impression.
mm,
So yes, there is this, I would say, this temptation of, yeah, data is not great, but that's fine, that's good enough, blah blah. Well, at the end of the day, it's
mm.
only good enough if you have a product that works, right? And
Yeah.
that's the final decision.
Yes, and maybe to switch gears a bit, did you have a mentor that profoundly influenced you in your career so far? That had like maybe somebody inspired you to go into genetics, and it was not just you as a kid wondering about this or that.
I, I don't think so. Not in the way that
Mm,
the way you explained it. My dad is a medical doctor, so
mhm,
I liked biology from a young age, but he's not interested in genetics, which is also always
mm,
a fun discussion. I
mhm,
think if I had to say that I had a mentor, someone that deeply influenced me, it's not someone that I met in person. It's actually someone that died before I knew him, knew of him, is Carl Sagan, which is this
mhm,
astrophysicist and science communicator communicating about the beauty of the cosmos and our place in it.
mhm,
And I it's not about genetics, it's not about synthetic biology, but it's about the wonder of nature, the wonder of the universe, and what a special place we have in it and what responsibility we have to take care of it. So
mhm,
I think this is the most influential figure that I had, is Carl Sagan, but I never had really a mentor or a teacher that really influenced me. I would say positively. I had a lot of
mhm,
people that mentored me, and technically, and I'm extremely grateful for. But
mhm,
the inspiration, I think, came from reading sci-fi books.
mhm,
June was a fantastic inspiration because it's
mhm.
about sci-fi without computers, which is interesting. So it was mostly remotely people that died some time ago that inspired me.
Okay, interesting. Can you maybe tell us a bit about the interesting trends that you see in the industry outside of what you are doing directly? Stuff
Hmm.
that excites you, where you say, "Okay, this probably leads to something."
Yeah, there's so many things, and every month I meet a startup that's doing something completely insane, completely crazy. Most of them won't be able to get to market. But if a tenth of them do, I think the world we will live in 5 and 10 years will be extremely different. It will really shock, I think, the world, the amount of innovation that's right now in synthetic biology, in the field of genetic engineering, etc. Obviously, AI is something that will drive things forward much faster. Um, and but even without, there's already innovations. For example, in the field of cultivated meat, you can create a steak without killing an animal. Just the fact that you can grow chicken nuggets in a petri dish, so to say, or in a bioreactor. So I'm friends with a lot of startup founders working in cell-based salmon, tuna, chicken, foie gras. I don't know how to say that in English. Obviously,
And
that one is a French one, and
yes.
uh, and yeah, just beef. And so I think this field is going to be massive. Like, will change the world massively as soon as you get to profitability when it comes to yield, and make sure that there's no safety issues. I think our grandchildren will look at us very weirdly when we're going to say, yeah, we used to eat animal carcasses every day. I think they'll look at it quite seriously. So this is a field that I think is very interesting. Another one is biomaterials, like uh, leather that's made of mushrooms, or silk that's made with yeast, or ink that's made with bacteria or yeast. Um, there's a lot of companies working on this stuff, and I think it's fascinating. I think replacing petroleum-based products with uh, products that you grow, you input CO2 and sugar, and you output anything you want, insulin, pharmaceuticals, dyes, anything like this. This is just fascinating. I'm looking forward to the day when I'm old, where I can just have, instead of a toaster, I have a bioreactor in my kitchen, and I just can click on, okay, so I want a steak in 1 hour. Just grow me a steak right now. Or I want to buy this, pharmaceutical. I want to create my own paracetamol. Don't have to go to the pharmacy. I just, this bacteria will grow and produce what I want and purify it. So I can see this future happening, and I'm really looking forward to it.
Mhm. One of the big issues, especially with the stuff you mentioned, like meat maybe leather and silk, is to hit the price point, right?
Yes.
This is what they're all fighting with, to hit the price point, and sometimes to make it competitive with nature, especially when you talk about plants. I think it's a bit easier maybe with animal replacement.
Mm.
But when you are trying to replace what plants do and do it in a more efficient way, then it gets really tricky oftentimes.
Yes, it's all about the numbers, like yield, scalability, and reproducibility. When you
Mm,
take, specifically when we talk about cell-based anything, whether it's a factory or a food, um, you're going to have variability within nature, within biology, that you
mm,
don't have when you work with entire organisms. That's
mm,
one of the advantage that we have. We work with entire organisms, so the way we produce it, it's not in bioreactors, it's just by growing a plant, and this process
mm,
has been streamlined 100 years ago. So we don't have
mm,
to change the production process. We just have to multiply what we do only once. But yes, for these kind of industries, about scalability, unit economics, and when do you reach profitability. But as soon as you do, I think it's a no-brainer. You will have, for example, salmon that doesn't have mercury or microplastics in it,
yeah.
that is molecular grade salmon, right? So not only will it replace, but I think it will be much better than the products we eat today, even without talking about the ethical, like animal cruelty part, or the environmental impact, just a pure product.
Mm,
And I think this is what people should focus on. And I think the good companies focus on that. It's, how can I make the product better? And that's
mm.
what matters at the end of the day. Because if you do all the great positive impact on the environment, but your product is not good, you will not sell it, and you will not have an impact at scale.
Yeah, yeah, definitely. You mentioned that an advantage at Neoplants is that you have the whole organism, the whole plant that you can work with. I always thought that this can be a problem because maybe you can't iterate so fast. Have you what have you done about this? This must be difficult.
It's extremely difficult. So let me precise my statement.
Mhm.
It's great when it comes to the production process.
Mhm.
It's a nightmare when it comes to R&D.
Okay.
So we finished finished. We reached the milestone that we wanted for microbiome R&D like years ago, right?
Mhm.
Because iteration cycles is what's when people talk about startups, they think about agile methodology, iteration
Mhm.
cycles, etc. When you're talking about a plant that's a year from transformation, so inserting the DNA to when we can test the DNA,
Mhm.
um, that's that's challenging. So the main challenge was, okay, what kind of proxies can we do to iterate faster? So
Mhm.
obviously we can use model plants that grow in 3 months instead of a year. We can
Mhm.
also use individualized cells of our plants. So insert the pathway into cells or an organ like a leaf, test
Mhm.
it at small scale. Does it do molecularly what you want it to do? And then extrapolate, okay, therefore I think that this is going to be the impact of the entire plant. But at the end of the day, the only thing that tells you if it works or not is the entire plant. So you can have a little proxies, you can de-risk a bit,
Mhm.
but that there's only so much you can do. At the end of the day, you need to wait for the product to grow and to see. So it's a lot of parallel work
Yeah.
as well. So instead of transforming one plant, we transform like 100 different
Mhm.
codes that we insert inside the plant because we don't have the luxury to iterate. So
Mhm.
a big chunk of what we do is useless, and we know it, and we need to
Mhm.
be able to live with it because it's after the results that we can say, okay, this is the result, this is the line that we want to go with.
Mhm. And this is probably also one of the promises of what people now call AI, at least
Yes.
when they are investors, um, of having a better proxy, maybe, or doing a lot of experiments, trying a lot of things out, like doing 100 plants in parallel with slightly different variations. And then basically you can't afford to iterate, but maybe if you can maybe have a computer simulate what would happen in a machine learning model, then this becomes much easier, and this will probably cut down the time. Right? This is, I guess, what you see as promising in this field.
Yes, for sure. I think it will massively cut down the time, and I hope it will give us better solutions that we couldn't think of as humans. I see AI in general, machine learning, as the computational tools of physics. Like you use computers to solve physics, I think you
Hmm.
will use AI to solve biology.
Hmm.
That's how I think about it because I think it's made for it. Biology is fuzzy. Biology is extremely complex. Complex is an understatement. There's so many variables that what we tend to do as biologists is to isolate them, test one after the other, because that's the only way we can function as humans. But
Hmm.
when you just dump the data into an algorithm that's just blind, you will come up with things that you would never have thought of before. And so this is why like I think AI is made for biology, in my opinion. And I think that in the next few years, we'll see some really cool applications that would have been impossible to do. Not just impossible to do as fast, but just literally impossible to do without the the advice of our AI partners.
Yes, only the big problem currently is most AI is made for lots of data, and then you have the
Yes.
problem of not so much data in biology. So we first have to solve that problem.
Yes.
Okay. So maybe to wrap up, what advice would you give to somebody who starts out today with a biotech startup?
It's difficult to choose. So that's it. The person is just started with a biotech startup and it's just the
Mm,
very beginning. So obviously there's I would say the normal advice. Like it's going to take a lot of courage, a lot of great determination. There's going to be moments where you're going to cry in the morning and just be jubilant in the afternoon. This emotional roller coaster is real, um, and yeah, your relationship with your investors and employees and everything. You need to be good at handling relationships as well. Um, but if I had a really good like technical advice as a CTO to give to any other CTO of a company would be take the time to put your tests, set up your tests and your protocols before working on the product. put everything you need in place around the product before starting to develop the product itself. And that's, I think, something that's the big learning that I had. You can start the product quickly and iterate, etc., but if you don't set up the good testing methodologies and the good ecosystem that's around it, you'll spend twice as long to develop your product. So uh, down to earth advice is set up the testing methodologies and the tests before you set up the product.
This is very interesting that you say this. I'm not sure whether there's a technical term for this in biotech, but there is actually in software development, which is test-driven development. It's exactly the methodology that you lay out here, which is to say, okay, I want to implement this and that in my software. First, I write tests, and then I implement what I actually want to do. This is
Yeah, I
very
didn't know that
interesting.
existed. Yeah, it's
Yes.
exactly that. Awesome. I'll
Yeah.
need to read up on it then.
Yeah. Read up on it. It's quite different in how you do it because obviously you only quote unquote have to write code, but
Mm,
it's exactly what you say. And yes, I can definitely chime in on the emotional roller coaster. Morning and evening, start of week, end of week can be extremely different.
yeah.
Super, Patrick. Thank you very much for being a guest in Machines and Molecules. And
Thank you.
I
Thank you very much,
hope we
Ingmar.
see each other again. Thanks.
Yes,
Bye bye.
will do. Bye.